Hello, welcome to NMK206 Computer Architecture. In this video, I'm going to show you how to add a test bench module and run a simulation. Okay, so now we add another module. Add the project, new file, which is Verilog. So again, if you are in my class, there are a few rules regarding this. A test bench module is usually named after the circuit that we are testing. And append underscore tb to it. Okay, so same thing as just now. You just have to take it as it is for now. This will be discussed in class. It's just a standard test bench module for most computer logic. So we are instantiating our design here. We can write it in full. So usually I only use DUT for this, but I just want to make sure you understand what that is. So we have an initial block. So one thing that is different from C, even I make this mistake sometimes, there's no loop plus plus in Verilog. You need to write in full, loop equals loop plus 1. Oops, mistake there. And we end it like this. So that looks okay. Okay, I missed one. Our circuit is my logic, not my one logic. So save that and compile. So make sure you get another tick. So okay, we are ready for simulation. Okay, to simulate, as you can see here, there is an option to start simulation and everything, but I'm going to show you something different this time. If you remember our library window, right? Now we have something in our NMK206 lab library. We have our two modules. So usually, like I said previously in the previous video, we simulate our test bench. So you select the test bench module, right click and select simulate. Okay, everything looks good. Both modules have been loaded. Next step is to select the signals that we want to view. We will be using the waveform viewer available in Modelsim. So we just add wave, right? So we only need to see the input and outputs, but sometimes it's also useful to look at other things internally. So for that, I'm just gonna add loop to the waveform just to show you what that is. So you need to run the simulation. By default, it just prepares the module, and simulation time is at time 0 at the moment. So you might wonder how long you want to run a simulation. So that depends on your code actually. If you remember in my test bench code, that #10, that's actually a time unit delay. So that's 10 time unit. It's called time unit because the actual time can differ between simulation tools. So in Modelsim, at the moment, at this stage, this version, one time unit is equals to 1 picosecond. So #10 is basically for 10 picosecond. So if you look at the scale, it is in picosecond, but you may not be able to see a 10 picosecond cycle. So what you want to do is Maybe you can enlarge this a little bit, and you want to open up the scales. So I think it's this one. So if you want to zoom in, so make sure you can see a 10 picosecond scale, or else you will not see the difference, the variations. That looks good. Okay, now you simply run for 40 picosecond. Why? Because one cycle is 10 picosecond, right? Hash 10, and you have 4 possibilities for 2 input gates. So you can just do run here, and you get your waveform. So the next question is, how do you analyze this? What does this mean? How do you know that your circuit works correctly? Well, number one, you need to know what your circuit is. This is a 2 input AND gate, so the logic must be AND logic. So since A and B are the inputs, so for each cycle, right, what's a cycle? Cycle is, remember, 10 pico, and remember the hash 10 delay is within a loop. That's why I asked you to insert the loop values here so that you can see the cycle. So this is cycle 0, cycle 1, cycle 2, and cycle 3. Maybe you want to zoom this a bit more. So in the first cycle, when A is 0 and B is 0, you can click cursor here. So when A is 0, B is 0, the output is 0. So that's correct, and logic. 0 and 1 gets you a 0 still, correct logic. 1 and 0 still gets you 0, correct. And lastly, 1 and 1 will get you a logic 1. So that shows that our circuit correctly represents a 2 input AND logic. So basically that is how you run simulation. If you are in my class, again, I will show you another way to verify your circuit without having to look at waveforms. Waveforms are nice, but sometimes you don't need to look at waveforms. You just need to know if it's correct. So I'll teach you another method to verify your circuit. Other than that, I think that's it. So I'll see you in class.